Hello and a nice welcome to our next webinar in our series, Your Challenges, Our Solutions. My name is Dieter Wagner. I'm a consultant at the Alplan Infrastructure Competence Center in Graz, and I would like to guide you through our today's webinar, which is called Axis-Related Modeling. So today, everything will be about axis. So what I would like to show you today, today's webinar is split into two parts. First, I want to give you a theoretic background of the possibilities we have about using Axis in Alplan Bridge. And in the second part, I will show you all these theoretical things in a practical live demo. You can already see here in the content about the axis that we will talk about today, but I will give you the details during the webinar. So to give you a bit of an introduction, of course, you might say now, I know how to model an axis in Alplan Bridge, of course, because that's usually what I do before I start, before I can model my superstructure. And yes, of course, that is one of the axes that we have in Alplan Bridge, but there is a lot more about this. So we can also have like boundary axis or terrain axis, which are actually not special types of axis. They are just created as a normal axis. So I just call it main axis here in order to distinguish it from the other axes. So it's also a normal axis, but we just use it for a special purpose. Therefore, I just call it here a boundary axis or terrain axis. You will not find those terms in the program, however. But there are in fact two special types of axis, which is the accompanying axis and the transversal axis. And they are always related to a main axis. So these are the types we will now investigate a bit more. So let's start with the main axis. That's probably the one that you know already best. However, there might be some points that you, maybe they are repetition or maybe you have not known yet. So let us quickly step through these issues. So first of all, how to get the main axis into your Alplan Bridge project. First of all, there's the manual definition. We will see in a second how this works. Of course, we can also import our axis via a land.xml file using the PIM plus connection. And there are some, I called it workarounds. So actually, they are maybe not the recommended workflows, but there is a possibility, however, to get the access from Alplan via Alplan Road or even PIM Plus also into the project, or convert it from a D40 file, which is commonly used still in Germany, for example. But let's have a closer look at these points. Let's start with the manual definition, which you probably already know. So how do we start? We always start with a starting point so that we place in a local or global coordinate system. And when we place it in the global coordinate system, we need to take care that we use the correct types of coordinates. So, you know, in Alplan Bridge, we have the coordinate system that you can see here on the left bottom corner. So we have the east axis or the x-axis to the right and the north or z-axis upwards. And the angle that you can also define already within this point starts from the x or east axis. So having the data available in some other coordinate system like the Gauss-Krüger system, of course, you need to take care that the coordinates might be different there as seen in this picture. So you just need to recalculate the starting point and the angle to get your axis in the right direction and on the correct position. Also, this often uses GON as for the angle, while our default setting is degree, but you still can change this also in the project settings of Alplan Bridge. I will have one more comment about this big or large coordinates in a minute. So having defined the starting point, the axis has the right starting position and the right angle. And starting from there, we will now add consecutively one axis element after another. So like in this example, we have a straight line, we have a spiral, and then we have a radius. And that's how the axis is set up in the plan. For the elevation, we define the tangent intersection points by a course of polygon points. So you can see here these red points. So they are the tangent intersection points, and they are connected initially by straight lines. So you always define it by a station and a certain height. And after that, we can, of course, round those or give a rounding in the points by a circular or by a parabolic arc to get the final curvature of the profile. Putting these two views together, we get the axis in 3D. As you can see here in the picture, I want to note that it's not essential that the length or the starting and the end point of the plan and the profile must completely correlate, so they can be different. But of course, the range over which you want to create the axis, this must be covered in both of the views. And of course, the axis is fully parametrical, which means you can, at any state of the project, you can always go back, change any of the parameters, and your whole, not only the axis, but the whole structure that is linked to it will be updated. That's about the manual definition, and let's have now some comments when using these large coordinates. So when you use like the Earth coordinates, they are quite big values, and moreover, when we calculate or display the axis in Upland Bridge, we often use the square of these values, and they can get really big, and then the program gets confused and cannot calculate or display the axis correctly. So when you use these large coordinates, and it's exactly the same issue than in Alplan, then you just need to define some offset values. I will also show you in the live demo. It's quite simple. You go to the settings, define the offset values, and you don't have to take care about it anymore. So just to illustrate a bit of the background. So let's say we have here the starting point, and so I just have displayed it here for for the east direction. Of course, the same applies for the north direction. So this would be now a really big coordinate where your axis starts, and the program cannot handle that value. So we will define in the project settings some offset for this east coordinate, and then of course the program can easily subtract this offset, as can be seen here, from the actual value and get this differential coordinate value starting from this offset point. And this is of course then a small value the program can handle, and then everything is fine. So I will show you also then in the live demo, you just take care about these offset values that must be in the range of the coordinates, the actual coordinates of your axis, and then everything works fine. Where do you define this? I already mentioned in the project settings. So here you can define these offset values. And of course, you must use the same offset values that you also use in Alplan. So it could be often the user starts already in Alplan with his project, or he has already some project where he needs to place a bridge structure. And then of course, you need to use the same offset values that you've used in Alplan. So they are not automatically transferred to Alplan when you import the model from Alplan Bridge on purpose. So we do not want to override the offset values if you have some there, because they will disturb your project. So you need to just take care that you have the same defined, and then also take care that the Y and the Z value, so the Z value in Alplan Bridge corresponds to the Y value in Alplan. Yeah, so that's what I wanted to comment about using big coordinates. And coming to the last point of getting the access into the project is the import. And here we recommend using our integrated file import of LandXML using the BIM Plus platform. So the brief workflow is upload the access to BIM Plus. Then you can directly log into BIM Plus from within Alplan Bridge. Then just choose the project and the wished axis. So let's have a quick look. There's a video showing the workflow. So here we are in BIM Plus, and we have already some project, and to the model we upload the file of the axis in terms of LandXML. It has been imported, and we can already view it in the viewer, in the Explorer project navigation of the BIM Plus. So we can double check it already here. And then going back to Alplan Bridge, we log in into BIM Plus to connect with the project, choose the project. And once the project has loaded, we can then just, here pick the wished land.xml file, or this was the model, and then select the file from the model in order to import it, and then we have the axis available in Alpine Bridge. Yes, here's the 3D view of it. Okay, this was about handling the main axis. And the first, let's say, special axis that we want to discuss today is the so-called boundary axis. As already mentioned, this is not a term that will occur within the program. It's a normal axis. And usually we use it together with an implemented function, which we call like calculate distance to a second axis. So I will illustrate this here on the next slides. As you can already see here in the navigation window, the boundary axis is in the same menu on the same level as the main axis, what I've already mentioned before. So the program at that point doesn't distinguish between the two. And you can also see it here in the plan view. I have a main axis and I have just another axis, which I call boundary axis because I will use it for that purpose. And what I want to do here, just for example, I will link a deck, a slab, a simple slab, to my main axis. So this will be my main structure. And on the left side, the slab will have a constant width, but on the right side, I have assigned a variable for the width or half of the width. And this variable should always be linked to the boundary axis. So how can this work? Using this function, the program will, at the available station points, he will make orthogonal cuts, orthogonal to the main axis. So I can choose actually to which axis the distance should be measured. You will see in a second. But here it's just orthogonal to the main axis and cut it with the boundary axis. And then we get the corresponding value at each station point. And this value is then assigned to the variable of the slab. And in this way, okay, here first we see how this is done in the program. So again, I have a main axis and I have a structural member, which is called main girder here, which is linked to that main axis. So just a normal superstructure. And the cross section that is assigned to this girder has this variable width. And in this variable, in the variation menu, I can then use this function for referring to the boundary axis. You see, this is now the second axis that I've defined. And within this function, I say, now measure the distance at each station point and assign it to that variable. And in that way, the cross section always has the width exactly to the boundary axis. I will also have an example in the live demo for this. And this is the result. You see here on the left side, we have the constant width, but on the right side, the program has evaluated always the distance from the main axis to the boundary axis. And thus we have a nice variating deck slab. Just some remarks to the usage of the function. Actually, in Alplan 2023, it's now totally selectable. So, but just to understand how the name is set up. So first it's just the name of the function, and then followed by an underline, we give the axis name that we refer to. So this is our boundary axis. And then we have two arguments in brackets. So one is how the distance should be measured to the main axis or to the boundary axis. That's what I mentioned before. And there is one default value, like if there is no, like let's say the boundary axis is a bit shorter than the main axis, and the orthogonal cut doesn't give a geometric result, so it doesn't intersect, then you can say which should be the default value that the program should use instead. And the very same function can also be used in the vertical plane. So the function is then cdh for the height, and it works exactly in the same way. So you can measure the distance in height between two axes. And one important remark, so usually it's not a problem to use blanks in the axis name, but if you use that function, because that's calculated, operated internally, this will not work if you have a blank in the axis name. So this is what you need to take care of. I will also have an example for the boundary axis. And let's step over to the next axis, which is the accompanying axis, which is not really, yeah, it's a bit similar, but it's also different. And I will explain the difference now. So this is an axis that follows the main axis in certain distances, which you can define. So, but the first difference is when I define the accompanying axis, it's always related to a main axis. So therefore, you will also find it in the context menu of the main axis. So it's not an axis that can exist by itself. It is always related to a main axis. And it has no station by itself, but the station is always also measured on the main axis. And the distance that the user can define, either in terms of constant values, but also in terms of a table, they are then applied from the main axis in the direction that the user has defined. And the points that they create, they are then connected with a 3D spline, resulting in this accompanying axis. Just recapitulate. The difference is that I don't have the axis data of this accompanying axis. I don't have the starting point and the radius and the spiral and so on. This was actually a user wish that was often referred to us. I say, like, they measure the distance from the main axis, like they have the distances to the curb, so to the edge of the section, and they were desperate because they could not define this axis, because they say the stationing is measured along the main axis. And now this is also possible, that you relate certain values to the stations, to the main axis, to create a boundary axis, which is now here an accompanying axis. And then you can just use it in the same way like the boundary axis we've used before, like in order to attach the edge of a slab to it. I will also show you this in the live demo. The next axis type is the transversal axis. So this is suitable for all parts that are like orthogonal or transversal in transversal direction to the main structure. So it's mainly used for cross girders, but you can also use them for pile caps or pier heads or whatever. So if it's suitable. And also this is a special type that is always related to a main axis. So this is the second type that you will find in the context menu of the main axis, because it will also be related or linked to an existing main axis. And this is the first thing that you need to define. When you create the axis, you set the station point on the main axis where it should be linked to. And then you have some more input in the upcoming input window. So first, it is the length of the axis. And here, to make the input easier, it is symmetrical to both sides. So like if you input a length of 10 meters, or here it's 8 meters, then it will be measured 4 meters to either side, because usually it's symmetric. But of course, if it's not the case, it's not a problem. So this is just the axis, right? So the cross member itself, of course, it can be applied within any station range on the axis. So it doesn't, of course, mean that the cross member needs to be symmetrical. And there are some optional inputs. First of all, what you usually would use is the vertical offset. So we do not want to link the transversal axis directly at the level of the main axis, but we have some vertical offset, which can either be constant or also defined in terms of a formula. And also optional, of course, by default, the orientation will be orthogonal to the main axis, but we can also have here a relative plan angle. So like it's the deviation from the orthogonal orientation that you can input here. And the same applies for the elevation angle, where you can also apply a certain inclination. Right, I will also, of course, have an example for this in the live demo. And the final axis, I call it here terrain axis. This is again a normal axis. So this is not a special axis type. So it's just a normal axis that we use for a certain purpose. And in this case, the idea is that I have the height of my terrain defined in one axis. and I can link the bottom of the piers exactly to this axis. So you know, since I think it's already 2 versions, we have a lot of possibilities for defining the piers. So they must not necessarily be linked to a reference point, but they can be linked to an axis or between 2 axes or an axis and a reference point. And so the bottom of the pier is linked to this terrain axis, and in that way it will always adapt. So if like the terrain axis changes its height, or even if I copy the pier along to some other position of the structure, then this bottom point will always be at the level of the terrain. So it automatically adapts to the height. This is the idea of this terrain axis. And to close this little introduction, the output, so all the axes that we can define can also be output in AlphaLambridge or in an Excel file. So the user can define the step width where he wants to output the data, and you see all the coordinates, all the defined parameters like angle, radius, and so on in a nice report that you can use for the processing your data. Okay, that brings me now to the live demo. So let me just switch to AlphaLambridge. So I've here actually a completely empty project, and I want to make a very simple example to show you all the features once more that we have now discussed. So first of all, I start with the main axis. So in order to show you something new, maybe I will use here Earth coordinates, the large coordinates, to show you how to define these offset values. I will just open some data. So my starting point will have Earth coordinates. So the first thing, I could do the options in the project settings. And you see here we have a menu for defining the offsets. And you will then see in a second, my starting point will be in the range of those values here. So I just copy paste them in this case here. So these are my offset values. Then I just confirm the input, and that's everything you need to do. So you do not need to care anymore about this. And now you will see when we create our axis, I will call it now here main axis. Of course, we know we will start with a starting point. And here we see now it doesn't start from 0, 0, but it already suggests these offset values. And my starting point is now exactly of this value, and my north coordinate is this value. And you see, just informatively, you already get the differential values, but you don't need to take care about them. Then here I could also define the angle. I don't need it for the time being. And you see now when I start, I have already here my real coordinates of the axis. And then I will just very quickly define some axis elements. So I start with a straight line of 40 meters to be added now to the starting point in the defined angle. Yeah, it's 0, so therefore it starts horizontally. Then I have a circle, and this circle has a spiral. Sorry, first I want to have a spiral, and I want to define it by a radius. So I could also define it by the parameter, and the radius at the end should be 500 meters. So at the beginning it's like infinite, so I just leave it to 0. And the length should be 100 meters. And finally, I also have a circle, and here the radius of course must be 500 meters, and the length I have is 174.6. And that defines my axis in plan. And you can see that I also always can double check now with the real Earth coordinates. Then for the elevation view, I will define some tangent points. So I will just start with the 0, 0, just to do this very quickly. Then the next one would be at the station 100, and it should have a height of 0.5 meters. And the last one will be also at station 174.6. And here, again, I have a height of 0 meters. Then I quit the action. Then I have here my tangent points, which I can now round. So I will round them by a radius of 3,000 meters. And let's say we want to do this parabolic. Okay, I recalc, and already I have my 3D spline defined by real coordinates. Okay, now just in order to be able to continue with some more axis, so the next one would be the boundary axis, I will just need some superstructure. So I will just quickly import a prepared cross section. So this is the main girder. So you see I have here multiple T-beam, and I've defined it in a way that I can, if I change the width, so there is a variable to the width of the right, to the right side and also to the left side. And you see, like, I want to change the deck width a bit, and I've defined the webs in a way using, just to show you this also, using this function line by relative factor. So this axis will always be at a quarter, so 0.25 between these two lines, so between the vertical y-axis and the edge, and this one will be at 0.75. So they will always remain in the same ratio, and therefore if I change, if I change the width, then they will always like move in accordance. So just in order not to only elongate the cantilever here. Yes, and so let's first define the boundary axis. And in order to not need to define it again, I will just copy it from the main axis. So that's also possible, of course. I can copy the main axis, and I will just move it a bit to the south, just to copy this again. So the east value will be the same as my main axis, but the north value I will put 5 meters more to the south, that I have a bit of an offset. And I've already calculated the angle here, so you will see then why this is exactly that value. So this will now start with a little inclination. So I confirm, and okay, maybe I should have given different name. I will call it boundary axis, and then I will just modify it. So I will delete the axis elements in the plan. So I just want to have one spiral here, and this should have a radius of -300 and a length of 40 meters. So just in the first 40 meters, you will just see in a second how this looks. So this is my boundary axis. The profile, it will just follow the main axis, so I can leave this like this, just recalculate. And you see that this axis now has a certain offset here at the beginning, and then after 40 meters, it will have a constant value. So I see I actually forgot to create the main girder that we should do now. So this is my main girder, and I want to apply it here using this cross section, just starting from 0 to the end of the axis. And I will take 5 meter steps. That's fine for me. And now we can see a bit better what I want to do. So we see here at the beginning, I want the width of the section to go to the boundary axis, and then it moves in more and more. And here at station 40, it will then have the constant width of the 4 meters I think I have here. So how to do that? You already saw in the presentation how this works. It's quite simple. So I go to the structural member of my main girder, to the variation menu. And I've already shown you how there is a variable to the right side of the cross section, which is called width right. And this is where we usually assign tables, but I don't know the values exactly, but I have the axis, I have the boundary axis, and this is what I can now use. So using the context menu, I have here the possibility of calculating the distance in plan to a second axis. That's exactly that function. Then here you see I can choose now, should it be perpendicular to the main axis or to the second axis? So I will have the main axis, and then which axis I want to use. So it's just showing all the axes that are defined in the axis menu. So of course I want to have the distance to my boundary axis. So when I select that, then it just asks me for that default value. So I say, okay, it should be 4 in case there is no result, and then click OK. And you see then all the parameters of these functions are already set up automatically. Then I want to assign this up to the station 40. And of course, I need to recalc in order that these values are filled. So you can already see the result here, but let us jump in here once more. So you see now that this function calculates the distance between the axes and assigns the value to the width of the cross section at the right. So starting from 5 meters and then going down to the 4 meters here. And also in the 3D model, I can see that here the width is exactly following these boundary axis. So I think it's a very nice feature to work with. Then the second possibility, which is now similar, I want to apply this now to the other side of the section where I want to have something similar using the accompanying axis. And you will see now this I need to create here in the context menu of the main axis. So this axis is related to the main axis. It's not an axis of itself. So I say new accompanying axis. And now I directly jump into the interactive input, and you see I have to define the stations on the main axis, in what range I want to define this accompanying axis. So I start at station 0 and I say again up to the station 40, I want to create that axis. And for the time being, I will just have an offset of 5 meters or minus 5 meters because it's in negative z direction. You can see here the coordinate system. And we will then define an offset table as well later, just to see how this works now. So you see that orange axis is now always at the distance of 5 meters to the main axis. And I can use this now also for example linking the width of the deck to it. But as I said, I don't want to have to jump here, so I also want to move this axis in, and therefore I want to assign a table. Let's just have a look at the property window of this axis. So you can see up to now I just have this constant value, but I can also define a table for this. And so this, let's say I don't have the axis data available for the edge of the cross section, but I know the distance measured from the main axis. And that's what I want to define here. So it's just a normal table, like where you define any other table. And I'll call it now offset for the accompanying axis. It's a bit long name, but just to know what we are doing. And then I will just define some stations here, 0. And of course, I want then not to have a linear transition, but I want to have a spline. So all these points should be connected by a spline. So I will just create first the values 10, 20, 30, and 40. And then I will apply starting from the minus 5 meters, minus 4.6, for example, minus 4.4. Sorry, there was a typo, minus 4.4. Then minus 4.2, and finally minus 4. And then I have something like this. And now going back to the axis menu, I will now override this constant value. So I say I want to assign a table, just select it from the list. You see it's already changing, recalculating, and it's already there. See, now it moves in according to the values that we have defined as an offset from the main axis. And then the final step is exactly the same that we had for the right side. So I go again to the variation menu of my main girder. And now I want to assign it to the value, to the variable to the left side. Do exactly the same thing. Choose the function, say perpendicular to this main axis. And now the distance should be measured to the accompanying axis. The default value should be like 4 again. And then I just need to take care. The value that is calculated will be a negative value, as we have defined the table in the negative z direction. But the value itself that the cross-section requires, like this, must be positive value. You see here, it's just a positive value. So therefore, I just need to put a minus here and then assign it again up to station 40. Recalculate. Let's just quickly go back to here to see. So you see now, this now gives me the minus, the negative value. Therefore, with the minus I have given, I have again the positive value for assigning it to the variable. And again, now calculated from the table, I have for each station point the respective value for the width of my section. So you see, it's two similar things, but again, the difference is the boundary axis is defined as a normal axis, having all the axis data available, and the accompanying axis is an axis where I just have some related values counted from the main axis. The next thing would be the transversal axis. And the transversal axis is again an axis related to the main axis. So you see, these are the two axis types that are available here. So we'll have new transversal axis, call it transversal axis. Okay, let me just undo once more. Transversal axis, yeah, call it trans axis. Then the program jumps directly into the interactive input. And I want to have a transversal axis here at the station 90. So I just pick that point. You can also, you see in the next window, if you don't get it correctly, you can always, like, I cannot pick it, and you can always enter it here, of course. And then it should have a length of 8 meters. So you see here, I can apply the plan angle and the inclination angle as seen in the presentation. And also for the time being, I will just apply a constant offset of minus 1.2 meters. So the height of my total cross section is 1.2 meters. The slab is 0.2 meters and the web is 1 meter. So it should be positioned directly beneath the bottom surface of my section. Yeah, so that's the position of the transversal axis. Now I want to create a cross member here, and for this I first also need to import a prepared cross section. So that's just a simple rectangular section. And then to create a cross member, it's not a special type. Yeah, it's just a normal structural member. So I will just say new girder and call it cross member or cross girder. And then the program asks me which axis you want to create a girder. So in this case, I pick the transversal axis and choose the cross section that I've just created, go from 0 to the 8 meters, and maybe I want to have 1 meter steps. And here I have created my cross member. Of course, now the question is, if I want to have it nicely defined parametrically, what will happen now when the height of my cross-section changes? So we have seen that the transversal axis is referred to the main axis. So this is my constant value. And so if the height of the section changes, of course, it will overlap. So the changing height of the section will not influence the position of the transversal axis because it's linked to the main axis. So how can we handle this nicely? And we can do this by a formula. So when we go once more here to the transversal axis, we see that instead of the constant value, we can also define a formula. And what should the formula be? I think it's quite simple. So it should be the 0.2 meters of the slab plus the height of the section. But this height of the section can change. So first of all, in order to be able to use this variable, we need to define a formula for the height of the section. So I'll show you how this works. So I will just have here in the variation menu where you define the tables, you can also define formulas. And the name of this will be height of the main girder. So actually it's the height of the web. So I just called it HMG. And let's just put it to 1 for the time being. So that's actually what it has already now. This is this 1 meter, the width, the height of the web. And now when we go to the variation menu, so maybe just double check again what this is. So this is this variable here, which changes the height of the web. So, and when we go now to the variation menu of the main girder, here we have here this variable. It's 1 meter as we have defined it. And in the same way as you usually define tables, we can now also assign this variable. So just drag and drop it to here. You see there's some syntax added, like the brackets open and close. And then I assign it to along the whole stations. And now if I change that formula like to 1.5 meters and recalculate, you see that, oh, once more, you see that here can I now directly set the value of the variable, right? So this is our formula. It's like a table assigned to the variable of the cross section. So changing this formula or this variable will change the variable in the cross section. And you see what happens now. I've changed the height of the section, but of course now it overlaps with the transversal girder. So in the second step, I want now to define the formula in order to set the axis always here at the bottom. So I will make one formula, which I call now offset of the transversal axis. And as already mentioned before, the value should be the 0.2 of the slab. So I say this is 0.2 plus, and now I can make use of the formula that I've created here, height of the main girder, plus H underline mg, and then I just need to take care of the brackets. And this expression I can now assign to the transversal axis. So in order to not have a misspelling, I will just copy the name here. So here at the transversal axis, where we up to now have the constant value of minus 1.2 meters, I will now assign minus and then use the result of this formula, which we have defined. You see it's immediately calculated even. I just need to recalc to also update the geometrical model. And you see what happens? Now it's exactly at the bottom of my main structure, which means I can go now here to the height, to the formula for the height of my superstructure, change it, for example, to 1 meter. So what will happen? The offset will be calculated now 1 meter plus 0.2, and the axis will be again at the right position. So in this way, I can make it nicely parametrically. So the last thing I want to show you is the terrain axis. And for this, I want to create some piers. So first of all, I want just to import the terrain axis, so not to lose too much time. So I will go to here and import the axis from TCL file. I've defined my axis already here. So you can see how this is defined. There is now a, this is again, sorry, I had this also yesterday. Let me just quickly, it's not displayed correctly here. Just let me fix this. There's something wrong in the, okay, now it's fine. This is the imported axis, and in the plan, it follows just the main axis, and the profile now reflects the terrain of my surroundings. And now I can link the piers that I want to create to this boundary axis, terrain axis, sorry. So I also quickly import some prepared section from TCL file. This is now my pier. It's just a simple two circular columns. And now when I create the pier, you see that we have now a lot of modeling functions. So we can create a pier at the station point directly, or relative to an axis, or relative to two axes. And what I will use is, I have here at the bottom of my cross girder, I also have a reference point. And I want to create a pier between an axis and the reference point. So I will use that function, pier. Then I choose the section. And I say I want to link it to that terrain axis at station 90. I could also define an offset from here, but I want to directly link it to the axis in my case, so 0 offset. And at the top, it should be linked to the reference point. And you see, this is possible because we can use here relative stations. So it's not absolute station values, but they will automatically adjust. And in this way, I have created the pier, the columns from the bottom to the surface of the main girder. And now let's just see what happens. Now let's say I change the profile of the terrain axis. Sorry, it's here. Sorry. So let's say here is the area where the pier is positioned. And let's just change it to 10 so that we can see something. Maybe also here, 10. We'll just recalculate. You see now the terrain goes up, and the bottom of the pier, the length, automatically adjusts. So in this way, I have a complete parametric behavior of my whole bridge. So let's just double check again. If I change one more time the height of the main girder to 1.5, you will see this will go down. The transversal axis will also move in accordance due to the formula, and also the height of the pier will adapt automatically. And of course, the same applies if you copy the pier along. If you copy the pier along the axis, the bottom will always be linked to the current position of the terrain axis. So this brings me to the end of my presentation. Maybe just one more thing. I mentioned also the axis report. So whenever you want to have the report of the axis, you just go to the context menu. So no matter which axis it is, you say show axis data. And then you can say the step within which the output should be done. So for example, 1 meter step. And then these are the main points that you have defined, like tangent intersection points and so on. You also want to display them. And then you see, then you have here all the coordinates and all the defined. So if you have the plan, you have the profile, and even for the 3D curve, you have all the data available. And you can also output this to an Excel. If you go to the results, it's a bit small screen. So here you have the Excel export. You just confirm. Takes some seconds. And then in the project directory, there will be subfolder reports where you have the Excel sheet. So this is just, need to adapt the columns a bit, where you get out the data of your axis. Just to conclude my presentation, I hope I could demonstrate that there are a lot of useful cases for working with axis in Alpine Bridge. So not just to describe the alignment of the superstructure, but you can use them in a very flexible way to intelligently and parametrically describe the behavior of certain structural parts. So I want to thank you for your attention at that point. I hope you got some useful information out of the webinar, and hope to see you next time. The next webinar of our series, it will be about BIM and interoperability, and it will be approximately 1 month, so you will get informed by mail in any case. Thank you very much, and see you next time, and have a nice day. Bye-bye.